Hello again. In the previous video, we have seen how to implement this simulation. Now, in this video, I show you how to configure PCs and routers. So the first thing I will start with is go to host 1 and configure the IP address. It's exactly the same as what you do with the real PC. I double click on host 1, go to desktop and then IP configuration, and from here you can choose static configuration by inserting the IP address, which is 192.168.100.1 with the default subnet mask 255.255.255.0, which is equivalent to /24. So I do the same thing with host 2. I go to IP configuration 192.168.100.2 and default subnet mask. Okay, host 3, same thing with host 3, 192.168.100.3 and subnet mask. Uh, of course, here we know that we're dealing with class C IP address. That's why I'm using the word default subnet mask for class C, which is 255.255.255.0. So I'm done with configuring PCs. Now I go to PC1 also. I will configure, go to desktop, and here I put 172.16.200.1. Okay, now here you notice this is class B. However, subnet mask should be /24, so I have to add 8 bits to 1. I have to add 255, so it's like we're subnetting a class B IP address. I do the same thing here. I go to desktop and IP configuration. I put 172.16.200.2, and for the subnet mask I have to add here 255 to bring the number of bits to 1 to 24 in the subnet mask. Okay, same story here. Put the IP address 172.16.200.3. Okay, put 255. Same thing for PC4. 172.16.200.4. Okay, and here I should change to 255 as before. Same story with the server. So the server here, I give it IP address, assign to it IP address 172.16.200.100 and the subnet mask 255. So now everything is okay. So I configured the IP addresses and subnet mask for each one of these PCs, including the server. Now I have to go to the router. Now let's go to the router. The first thing I can do when I go to the router is go to command line interface. Command line interface. Since the router does not have any configuration yet, it will ask you this question. When it boots, when it finishes booting, it will ask you this question: would you like to enter the initial configuration dialog? Say no, because you are going to configure it using using the right commands. So I type no. Okay. All right. Let me type no here. Okay. So now we are in this level here. We are in what we call the user exec mode. This is what we call user exec mode. Now this is normal user. You don't have a lot of power here at this level. You are just acting as a normal user. So if you want to configure the router, you have to move to the privilege exec mode, which is equivalent of administrator or root. So how to move to that mode? You have to type the command enable. Okay, you type the command enable, and you see here the prompt has changed. Previously it was greater sign. Now the prompt is a high sign. So when you see this prompt, it means that you are in the privileged exec mode, and in this mode you can do a lot of you can configure your router. So this is what you call a privileged exec mode. Now from here you can move to the global configuration mode by typing the command configure terminal. So since you are going to type the commands using the keyboard, so here you put terminal. Terminal is the old way of naming the keyboard also. Now you see the prompt has changed. You have this between parentheses, you have config. So here we are in what we call a global configuration mode. This is a global configuration mode. Global, it means that whatever commands you type at this level is going to affect, or whatever configuration you will do at this level, it will affect all the router. So this is the global configuration mode. So the first thing I can do here is to change the host name. Now here the initial host name of router by default is router. So any router without any configuration, when it doesn't have any configuration, its name is by default router. So I'm going to change it. I will use the command hostname, and I will use now the new name of the router. Now notice that once I press on enter, the name will change. You notice now the name has changed to RTR1. Now after that, I have to search what I can do. I will do something. First, I will exit the router. Okay, I move again to the privilege exec mode. As you notice here, this is what we call a privilege exec mode. From this mode here, I'm going to type the command. I need to display my routing table, so I will write show IP routes. So what do you notice? You notice that my routing table is empty. There is no information. The only thing you can see is the significance of the characters here only, but in fact there is no route entry. So now I go back again to the global configuration mode, and it's very simple. Just type conf t as a summary. So just you type conf t to speed up, and then you go back again to the global configuration mode. From here you move to the interface mode, to the interface configuration mode. I type the command interface, and then I specify the name of this command, which is fast Ethernet 0/0. So now I'm inside the interface configuration mode. Interface configuration mode, and while I'm inside this interface configuration mode, I can assign IP address by using this command IP address, and then I specify IP address 192.168.100.250. Of course, the subnet mask should be written in the form that we have already seen. This is what we call the dotted quad decimal notation. It should be written under this form, which is 255.255.255.0. Now by default the interface comes disabled. The interface is disabled. As you see, this is red color, red label here. It means that the interface is not active, so I have to bring it up. To bring up an interface in Cisco router, just type the command no shutdown. So this, which is the inverse of shutdown if you want to disable interface. No shutdown. You see now the interface, the color of label here turn to green color. If you want to speed up the convergence of this link, just go to fast forward like this. Now this full link, the whole link is operational. Now after I'm done, I go to exit, and then I will configure the second interface, serial 000. What I do, I type the command interface serial 0/0/0, and then I type the keyword IP address, and I put the IP address 15.0.0.1. Now the subnet mask should also be written in the dotted quad decimal notation, which is 255.255.255.252. Once done, just type no shutdown, but you notice that interface is still disabled. Why? Because it's point-to-point link, and this interface, although it's configured correctly, but since the other end is not yet configured, so the complete link is still down. So I have to move to the second router. Okay, we are done now with the first router. Now in order to exit from here, I can type exit, and again exit to move to the privilege exec mode. And once I'm done, I can save this configuration. For example, I can write I can copy the running configuration that I just typed into the startup configuration. So like this, I'm saving my configuration. Now if I turn off the router and then I turn it on, the configuration will always be there. Now I go to the second router. Let me just increase this window. Now I go to the command line interface. Again, I see the same question. Would you like to enter the initial configuration dialog? Say no. Okay, and then I am in the user exec mode. I want to move to the privileged exec mode by typing the command enable. Once I am in the privileged exec mode, I go to the global configuration mode. From there, I can change the name of the router, RTR2. Okay, after having done that, I just go to the interface configuration mode. Let's say faucet internet 0/0. By the way, you can type FAS and then click or press on tab. Is going to continue the command for you if there is no conflict. So once inside the faucet internet 00, I just configure the IP address 172.16.200.200.250, and the subnet mask. Again, it should always be written in the dotted quad decimal notation, 255.255.255.0. And let's bring this interface up like this. You see now this interface is a green color here, shown in green color, which means now it's active. To bring this link to active, I just fast forward, and then this link now is fully operational. I do the same thing with the I would do the same thing with the serial interface, but instead of exiting and accessing again, entering the serial interface from where I am now, I am inside the faucet internet 0/0. From here I can access the serial interface. Okay, now I am accessing the serial interface. I put the IP address of the serial interface, which is 15.0.0.2 to subnet mask. Okay, so now I bring interface up by typing the command no shutdown. Now notice what happened. Once I type this command, normally this link here should go up and become operational. So this is what happened because it's point-to-point link, so everything is fine. Now as soon as I bring this interface up, as soon as I have configured this interface with IP address, and I bring this links to upstate, and I type again the I display the routing table. Look what happens. Now the routing table are there. Before, when the two interfaces were disabled, there was no routing table. Once the interfaces now are configured with the IP address and enabled, automatically the router is going to insert information about the network which are directly connected to these two interfaces. So we learn from here that RTR1 is connected to network 15.0.0.0 through interface serial 0.0 serial 0/0/0, and that same router is connected to network 192.168.100.0/24 through interface faucet internet 0/0. So is this true? So this is what we see here. Same story with the other router. So let's display the routing table, show IP route. So automatically these entries are inserted in the routing table of the router. So RTR2 now is aware about these two networks which are directly connected to it through the interfaces serial 0/0/0 and fast Ethernet 0/0. Now, like this, if I go to PC host 1, okay, I start the terminal, I start the command prompt, and then I ping PC1, which is 172.16. For example, from host 1, yes, I want to ping 172.16.200.1. Is it going to work? Look what happens. It's not working. Why is not working? Because RTR1, as we have said through its routing table, knows only about these two networks which are directly connected through these interfaces. So it has no information about this network here, which is a remote network, because it's not directly connected to it. So let's go back here, and you see that ping failed, timed out, so it was not able to reach the destination. So in order to mitigate this, or to solve this issue, this problem, I have to go back again to router R1. I go to the global configuration mode like this, and then I have to configure static route. Now the static route here is very simple. What does it say? It should say the following. It should say the following is that I type IP route, if I want to reach network 172.16.200.0, if I receive a packet destined to for network 172.16.200.0, and you notice here I'm specifying network address with subnet address of a remote network. Simply forward the packet to the next hop IP address, which is 15.0.0.2. 15.0.0.2. Okay, so this is the static route. Now let's go back to our routing table and let's see what happens. There is a new route which is added, and this new route, we see there is mention here of the remote network address that is reachable across this IP address, which is the IP address of the next router downstream to the destination network. So we have to do similar thing. We go to RT2, and in RT2 I'm going to configure this IP route, and then I have to specify the remote network address. So network address will be 192.168.100.0, subnet mask 255.255.255.0, and the next hop IP address is 15.0.0.1, 15.0.0.1. It means that whenever RTR2 has to forward packet to this network, it has to forward it to this IP address 15.0.0.1. So now we can stay here, and if I want to display routing table from within the global configuration, I can do this command do show IP route, and you can display your routing table. So we know now that RTR2 knows about the existence of network 192.168.100.0 through configuration of a static route. How do I know that this is static route? Because of S. And in order to forward the packet successfully to this destination network, it has to send it to this next hop IP address 15.0.0.1. Now let's go back to host 1. Is it okay? Now can it reach the destination network 172.16.200 and communicate with host 1? Let's see what happens. Is it going to work? Yes. No, definitely it looks like it's not working because there is an issue that needs to be also addressed. Computer, it knows that host 1 knows that the destination 172.16.200 is a different network, because host 1 has this IP address 192.168.100.1, and it wants to communicate with 172.16.200.1. so these are different, hosts on different networks. So we have to go to host 1 and keep on and configure the default gateway. So what is default gateway of host 1? It is 192.168.100.250. So it's nothing but the IP address of the interface of router which is connected to the same LAN, which is in our case 192.168.100.250. Okay, so we have this default gateway. Now I go so to host 2. I will do the same thing. Okay, host 3. I'm going to paste default gateway, so all computers in the same LAN should have the same default gateway IP address, right? Here I go to PC1, same story. What is default gateway of PC1 in the second LAN? It is the IP address of fast Ethernet 0/0 of router RTR2. So this is the default gateway. It's always the IP address of the interface of router which is connected to the same LAN. So it will be 172.16.200.250. Now let me just copy this. I copy it, and then I will paste it in the other host. Of course, we need patience here to finish this. Same thing with PC3. This is PC3 and PC4. PC4. Right, and we should not forget the server. Okay, so the server is running there. Paste. Okay, so everything is there, and don't forget the server. You just go to services and you see what type of services it's supporting. In our case, let's just consider the web server, HTTP server, so which is on state. Now after we finish, let's go back to host 1, command prompt, and ping again. and let's see what happens. Now everything is fine. Now it's working successfully. Now it's success. Now it's replying. Okay, so now there is round trip between the PC host 1 and PC 1, so I can also ping to the other PCs, which is PC 2. It's working fine. Now everything is okay. It's replying, right? 3 also, it's reachable. Okay, so timeout, it's reachable. So later on we're going to talk and explain why we always have this request timed out in some situations, but for now it's okay. Everything works fine as normal. And also the server, which is 100. Okay, so the server also is working fine. That's great. So now if I want to test the server, to test web server, I can start the browser on PC1, and in the browser I type http :/172.16.200.100 is the IP address of the server, and then I have access to the web site which is running on this server. So it's just simulation. Very good. So after I have done that, I can go to, for example, host 4 and check and see what is the route from host 4 to, let's say, PC4 or to PC3. From command prompt I can use now the trace route command. In Windows it's trace RT. Specify the IP address of PC3 200.3, and then this is the result. So the first IP address here, what you see is nothing but default gateway of PC4, okay, of host 4, sorry. This is default gateway of host 4. The next IP address is the IP address of the second router, and the last IP address is simply the IP address of the target. So trace route will give you the set of routers between you and the target. So how many routers we have? We have 2 routers, because the third entry here indicates the target to which you are trace routing. So remember, with trace route, whenever it generates n entries, so it means we have n minus 1 routers, because the nth entry is simply the target we are trace routing to. Okay, so I'm going to stop this video here, and in order to get the best experience with the Cisco packet tracer, you have to practice and create a different scenario, and you can use, for example, different routers with different number of ports. As you can explore here, you see there are different types of routers. Try to play with this static route.